Swayam Prabha. Digital India. Educated India.
Hello friends, so in this lecture we will discuss about the application of artificial intelligence based techniques used in digital protection of power system network. So, the question comes, why to use AI based technique in protection area. So, we know that the performance of digital relays can be substantially improved if the decision making of those relays that can be done using AI based techniques. So, the performance improvement can be in terms of selectivity. So, if you use the AI based technique, then you can see that performance in terms of selectivity that can be improved, and we can say that only faulty section that can be disconnected without affecting any healthy section. The second advantage is the discrimination or classification. So, if I use AI based technique for decision making in digital relays, then any event or fault that can be better discriminated compared to any other conventional technique. So, classification or discrimination between internal fault and external fault, or between in zone fault and out of zone fault, that can be done effectively if we use AI based technique in digital relays for decision making. The third is the sensitivity. So, if I used AI based technique in digital relays for decision making, then it improves sensitivity. So, definitely, even though sometimes it may possible that the magnitude of fault current is lower than the full load current of the feeder or the line. So, that type of cases that can also be detected by such type of techniques. The response that becomes faster compared to the conventional techniques, and if we wish to achieve or incorporate adaptive feature, then also we can easily incorporate whenever external system conditions changes, then whatever changes that is required in the settings of the relay, that can be done adaptively if we use AI based technique for decision making in digital relays. Now, let us see what are the features of AI based protection scheme. So, the first feature is that AI based protection scheme helps in developing a tripping logic, in which we can have adaptive logic also using several factors which is known as weighting factors. Uncertainty, if it is there in any signals which are acquired, may be voltage, current or any other signals, and if those parameters are used in the calculation of relay settings, then that can be also easily incorporated using AI based protection schemes. Further, this scheme also provides proper discrimination between in zone faults and out of zone faults. So, in case of in zone faults, relay operates, whereas in case of out of zone fault, relay does not operate, it remains stable. Further, utilization of this technique will also help in incorporating changes in relay setting based on change in external system conditions. So, this type of concept is known as adaptive protection. So, such type of feature that can also be incorporated in the relay if we use AI based protection schemes. Now, let us see what are the various types of AI based protection schemes exist. So, there are mainly 5 types of AI based protection scheme exist. The first is the neural network based scheme, second is the fuzzy logic based scheme, third is the expert system based scheme, fourth is the machine learning, and fifth is the deep learning based scheme. The fourth and fifth, that is machine learning or deep learning based scheme, both are more or less same, only the difference is because deep learning is again the subset of machine learning. So, we can say that these two categorize in the same category, whereas the other three schemes they are different. So, let us discuss each scheme one by one. So, let us consider first the neural network based scheme. So, if I consider the application of neural network based scheme, then that can be easily applied for detection of fault, classification of fault, or maybe location of fault in transmission and distribution lines. Why it is used? Because the neural network has a feature known as generalization and fault tolerant capability. Because of that, it can handle any unseen parameters, so that can be easily identified or classified. The second is discrimination between internal and external fault. In that application also we can use neural network based scheme, and it can be also used when we wish to obtain the discrimination between fault and abnormal conditions. Now, let us consider one case study of neural network based scheme. So, here you can see that the datas are acquired by data acquisition system. So, we have continuous data, we are acquiring the data, let us say at 1 kilohertz or 2 kilohertz or 4 kilohertz sampling frequency. So, we acquire voltage or maybe current or maybe both data continuously. We can go for a sliding window concept or moving window concept, and then if required those data can be featured also, that means feature extractions can also be carried out, because whatever data we acquire, let us say we acquire 3 voltage 3 current, then we do not require 3 voltage 3 current, we required only specific data, let us say 3 currents or maybe sequence components of voltage or currents or any other rate of change of sequence component or rate of change of voltage component. So, feature extraction play an important role to capture only the useful features based on which the classification can be easily carried out. The next block is nothing but the fault detection and direction estimation algorithm. So, trip signal is initiated only in case of forward faults that occur on the transmission line. So, here you can see I have shown one single line diagram of a single terminal transmission line network, where I have shown one fault that is termed as forward fault. So, any fault on behind this breaker, that is known as reverse fault. So, tripping is only initiated in case of forward fault, there should not be any tripping in case of reverse fault. An approach based on the status of normal power direction along with the directional discrimination function that can be used for directional estimation algorithm. Once it is there, means once it is confirmed that the fault is a forward fault, then we have to also simultaneously check that whether the fault is actually there or not, or it is some abnormal condition. So, whether actually the fault is there or not, and if it is there, whether it is in forward direction or not, that is confirmed by this block. Then after this, the output of this block, that is detection and directional estimation algorithm, is given to the fault classification algorithm, which is based on neural network, and we have fault location algorithm also, which is also based on neural network. So, these two blocks perform simultaneously, and if I consider the fault classifier block, let us say you have extracted the features and you are giving let us say 3 or 5 or 6 input to the ANN for training and maybe after that testing purpose, and then output of this classifier block, which is based on neural network, that is from 1 to 11 numbered, and this represent different types of fault with pre-fault condition. So, 1 indicates the normal or pre-fault condition, whereas from 2 to 11 that indicates a specific type of fault. During training of neural network, this outputs are assigned as number either 0 or 1. So, considering whether a particular fault is involved or not, you can have or you can classify the fault. For example, if you have the output let us say at 2 number block, the output is 1 and let us say others are 0, then you can see that fault is A to ground fault, and same way you can also classify some other types of fault. This classification approach considers a particular phase to be faulted if its corresponding value is greater than 0.5. So, instead of taking directly 0 on one logic, you can also take if anything above 0.5, then that classifier tells you that this is a particular type of fault which has occurred, or if it is below 0.5, then that fault that is not classified. Once the fault is detected, after that let us say the performance of this classifier block that can be carried out or that can be assessed by generating some unseen patterns or events, and based on that accuracy of that classifier that can be obtained. The decision logic block sends a signal to the fault location and activates the appropriate neural network, as I told you, which is different for different types of fault. And finally, this block also derives the trip or no trip decision from the output signals of the classifier and locator, which is finally initiated or given, so that the operator that is easily aware that okay, this type of fault has occurred and at this much of fault location it has occurred. So, then the maintenance can be carried out appropriately. Now, the second type of scheme, that is known as fuzzy logic based scheme. So, we know that performance of conventional relaying scheme that can be affected because of several parameters. For example, we have different configurations such as single or double circuit transmission line. We have uncompensated or compensated transmission lines, maybe series compensated, shunt compensated and so on. We have untransposed or transposed line. So, because of that performance of the conventional relay that is affected. Further, there are several uncontrolled parameters are also there, like fault location that is not in our hand, fault inception angle that is also not controllable, fault resistance and fault type. Because of these factors, the performance of relay is affected badly. Change in load generation or topology of the power system, that is also another factor. Errors in the measurement of voltage and current transducers, maybe errors in the relays, errors in the current transformers and potential transformers, that also going to affect the accuracy of the relay. And finally, the noise introduced because of the electromagnetic interferences, that also we need to consider or take into the account. So, all these 5 problems that can be easily resolved if we go for fuzzy logic based protection scheme. So, if I consider any fuzzy logic based protection scheme that can be applied to maybe for overcurrent or distance or for any other purpose, then it contains mainly 4 blocks. The first block is the fuzzification interface block. So, fuzzification interface block measures input quantities such as current, voltage or maybe their transients, and it also converts input data into suitable linguistic values which may be considered as labels of fuzzy sets, and this whole process is also known as fuzzification process. The second block that contains the knowledge base. So, knowledge base comprises knowledge of the application domain and consists of a database and a rule base. The database provides the necessary definitions to define linguistic control rules. For example, we have let us say rules like x is greater than y, maybe x is less than y, x is equal to y. So, such type of rules we can easily form depending upon the requirement or application. The third block, that is known as the decision inference logic block. So, decision logic block is a kernel with the capability of simulating human decision making based on fuzzy concept, and it also employs the rules of inference in fuzzy logic. And the fourth block, that is known as defuzzification interface, and in this block it converts the range of values of the output variables into corresponding universes of discourse. It also provides a non-fuzzy control action from the inferred fuzzy control action. Now, let us consider the third type of scheme, that is based on expert system. So, if we want to carry out settings of any digital relays or numerical relays or IDs, then that need an experienced relay engineer. This complexity increases in terms of different relay settings when relays are again procured from different relay manufacturers. Further, changes in the external system conditions also imposes an additional burden on the relay setting calculations or processes. So, as the relay settings are available in a rule style, so we can go for expert system based protection scheme. So, if I consider the block diagram of any expert system based scheme, then you can see that that contains mainly the 4 blocks, and these blocks are, first is the knowledge base block. So, here this block is known as knowledge base block. So, this consists of production rules used in representing a system's knowledge. This is provided by the expert to enhance the reasoning process. The second block, that is known as the inference engine, and if I consider this block, then once the expert gives the effective reasoning, then knowledge process is done by this block. It interacts with the user interface and accepts the description of the network from the user and supplies the relay setting results. This type of block, that is inference engine, also takes help of knowledge stored in knowledge base and draws some conclusions and such type of recommendations, that is also passed to the other block. It also takes the help of short circuit analysis algorithm to perform short circuit analysis if it is required. The third block, that is known as the database block, and it helps users by providing the required information to solve a particular problem. The fourth block is user interfacing block, and it helps the users to solve their problems by consulting the expert system. It also assists users by explaining the concept of various functions. Now, let us consider the fourth scheme, which is based on machine learning. So, we know that the artificial intelligence is a broader umbrella under which the machine learning or the deep learning algorithms are situated. So, you can see that the initially the artificial intelligence block is there, under which the machine learning and the deep learning both will work. Machine learning learns and makes predictions based on its experience or whatever past history or some data, whereas deep learning is also a subset of machine learning algorithms. So, deep learning used the concept of nested hierarchy, and hence it is more powerful than the machine learning and other techniques. Now, let us consider what are the different parts involved in machine learning based scheme. So, whenever we consider machine learning based scheme, that needs some input. So, we have to take the input or we have to acquire some parameters, then the pre-processing that has to be carried out on acquired information or signals, and this is required for the removal of noise. Then the property extraction is carried out. So, whatever features you need, that features only you have to use for the decision logic, and then based on that finally classification that is to be carried out by clustering or classification algorithm, and final decision that is communicated. So, if I consider the machine learning based scheme, then the characteristic of this machine learning based scheme depends on 4 parameters. First is the feature selection, second is the model selection, third is the exegesis and validation, and fourth is the model itself. So, if I consider the first feature, that is feature selection, then the aim of this is to decrease the data and dimensions of the input space. So, this is obtained by reducing the attributes that have not any beneficial information to forecast the desired output information. If I consider the model selection as another parameter, then these are selected that have the best fit of learning situations in the predefined class. This needs organized selection of the parameters and building of model using temporary search techniques or optimization approaches which are appropriate for the desired model. The third feature is the exegesis and validation. So, this is required to understand the systematic meaning of the model which is necessary to determine its validity, comparison of its information that can be obtained from the model with previous allocation or we can say past history, and after that the testing is to be done on a set of invisible experimental samples. So, this is required or very important when we go for testing. And the fourth feature, that is the model itself. So, the function of this model is to predict the output using assumed values of input parameters, and sometimes the inversion of the model is performed to prepare the information to change the input parameters in order to obtain a certain output. Now, based on this, if I consider the classification of machine learning, then machine learning algorithm that can be classified as reinforced learning. So, in that we have Q learning and deep Q learnings are there. We have unsupervised learning in which dimensionality reduction, clustering and HMMs are there. We have ensemble methods are there in which the bagging, stacking and boostings are there, and we have another supervised learnings are also there, based on which deep learning, neural networks, regression methods, Bayesian methods and classifications are carried out. So, if I consider application of machine learning based schemes, then this type of schemes that can be applied for load management or maybe load forecasting also, it can be applied for electric pricing. It can be also applied for reconstruction of certain data or parameters, restoration also we can apply. We can also use this type of scheme for fault classification and location or better estimation of fault, and then we can also use for security assessment. Now, the next method is the deep learning based methods. Now, before we proceed further, let us discuss what is the fundamental difference between the deep learning based methods and machine learning based methods. So, if I consider the deep learning based method, then feature extraction is done automatically in deep learning based methods, whereas feature extraction is done manually in case of machine learning based methods. Second is, as the volume of the data increases, the model in deep learning expands and better improvement with increase in data that can be obtained, whereas in case of the machine learning based approaches, as data increases the model expansion is only up to certain extent, thereafter no change is observed. The third difference is the deep learning based approach reduces the task on programmers to explicitly select the features, whereas no such facility exists in case of machine learning based approaches. And fourth one is the classification and feature extraction sections are merged, whereas both are separate in case of machine learning based approaches. Now, let us see what are the challenges faced by machine learning or deep learning based approaches. So, if I consider the first challenge is that is related to the cyber attacks. The second is the cost of such approaches that is very high. This type of approaches needs historical data. It is a new technology, we need skilled operators, and after obtaining the results from such approaches, proper evaluation of the results that has to be carried out. So, all these are the challenges of machine learning or deep learning based approaches when it is used for protection of a particular devices or the transmission line. Now, at last let us see how we can apply AI, machine learning or deep learning in a smart grid environment. So, the one example we can consider, we know that the electric vehicles are increasing day by day, and as we are shifting from the gasoline based vehicles to the electric vehicles. So, the concept of AI, ML or deep learning that can be easily applied in this case. For example, if I consider AI, ML or deep learning, then it can be applied for electric vehicle applications, where we need the research and development for battery of the electric vehicle. For state estimation and diagnosis purpose, we can use in charging control, range estimation, maybe we can use this thing in battery management system or energy management system of electric vehicles. If EV integration or electric vehicle integration is carried out with the smart grid, then we can use this AI, ML or deep learning in vehicle to grid mode, maybe grid to vehicle mode, maybe we can use for energy scheduling, we can also use to tackle issues with the grid, maybe modeling consumer charging habits, load forecasting and dynamic pricing. In all such applications, we can use the concept of AI, ML or deep learning, and we can design the method based on this. The next is the application related to the charging station of electric vehicles. So, optimal location and placement of charging station, that is also another area where we can use AI, ML or DL. We have charging station dynamics, customer satisfaction is also there, congestion and management during smart charging, and energy and congestion management. In all such applications, we can use the concept of or application of AI, ML or deep learning based methods or approaches, and we can design the appropriate methods. And one very important thing is, when we are dealing with electric vehicles in smart grid environment, then they need a huge data, and handling of those data we have to go for either the AI, ML or deep learning based approaches. So, in this lecture we started our discussion with the what are the advantages of application of AI when it is used in decision making of the digital relays. Then we have discussed the different types of approaches. We started with neural network based approaches, then we have considered the fuzzy logic based schemes, and then we have considered the expert system based schemes, and then we have discussed the machine learning and finally deep learning based approaches. After that, we have discussed an application of AI, ML or deep learning based approaches in smart grid environment, particularly when the EV integration is carried out in smart grid along with certain other renewable energy sources. So, we know that this is the last lecture of this course, and I hope that you have enjoyed this course. The different assignments that is given for each unit, and you will also carried out some exercises for each assignment. So, I hope you have enjoyed the course and I wish you all the best. Thank you.